So in this first example, I have given you two monomials. I thought it would be a good thing to look at what if it's all multiplied together versus some that have adding and subtracting. Seems like when it's all multiplied together, it's a little bit easier than when it's got adding and subtracting in it. Was that true on today's quiz? Was it easier to do the ones that didn't have any adding and subtracting in them? Okay. So, I wonder what the least number, and when they say least common multiple, they're saying what's the least number 4 and 6 will go into. So when you think of that, you have to think of your times tables. Like the times tables for 4 is 4, 8, 12, 16, for example. And then you think of your times tables for 6, 6, 12, 18. Wait a minute, I said 12 on both of them, didn't I? And that's the least one. So for your numbers, you have to think about your times tables, and you have to think about what's the least number they have in common on both tables. But with letters, you have to figure out, if you want to make the letters alike, you can't take any away, you can only put more to it. So if I have 2 x's here and I have 4 x's here, how many x's would I have to have for them to be alike? 2 more here, right? Because I already have 4 here, I'd have to go up to 4 to make them alike. Does everybody agree with that? So I need to pick the highest power? Okay. So how many y's do I need? 5, because there's more y's in this one than there is in this one. See, I would have to give this one 2 more, wouldn't I? And then, of course, there's z's in this one. There are not any z's in here, so do I have to have z's in my least common denominator? Yes, I do. So that's how you do it with monomials. You think about your times tables and you... 4 and 6 both divide into numbers. What is the smallest number that 4 and 12 go into? So you think times tables. 4 times 1, 4 times 2, 4 times 3, 4 times 4. And then you think of your times table. 6 times 1, 6 times 2. Wait a minute. The first one I came to is 12. They go into. This is not greatest common factor. I don't want to know what goes into them. I want to know what they go into. Does that make sense? Okay. Now, with polynomials, it's a little different. Because in polynomials, guess what we still have to do? Factor. So this one over here needs factoring so I can compare it to what I have over here and see what they have in common and what they don't have in common. Two numbers that multiply to be 10 and add up to -3. -5 and 2 multiply to be -10 and add up to -3. Now that's that shortcut method for the 5-step, right? We can't do that all the time though. So this one over here has an x that's not in a parentheses. Do I need that for the least common denominator? Yes. I have to have what they don't have in common. Now they both have an x plus 5, so that's pretty obvious. That needs to be in the least common denominator because they both have it. And then I have to have an x plus 2 because they don't both have that. If I want to make both of these alike, wouldn't I need to give this one an x plus 2? And wouldn't I have to give this pair an x? So they'd have to have all 3 items, what they have in common and what they don't have in common. No, it's not that they need 2. It means that each one has one. So you're trying to say, oh, I need to give this one an x plus 2. Now they have 3 things. I'm trying to give this one an x. Now it has 3 things. What are the 3 things they need? These 3. All right, stop talking and listen. So this one has a 2. This one has a 2x. What do you think?
They both have a 2.
They both have a 2, so obviously they need that. Well, is an x the same thing as an x plus 1? Oh, so they both need a 2 and an x, right? So this one would need an x to go with his 2. Would everybody agree? And this one would need an x plus 1. So that's why you need all of that. You have to give it what it doesn't have. If it doesn't have part of a monomial, you give it part of a monomial. If it has a whole parentheses missing, you give it a whole parentheses. I don't think so. It's pretty much this. Except for now, we're going to use this concept to add and subtract. All right, so we got to factor this to see what's in these parentheses, see if the parentheses over there have the same stuff, or at least some same stuff. Plus 3 and minus 1 make 3, but add up to 2. What about this one over here with negative 12? X minus 4 and positive 3? Add up to negative 1? Well, what does this first one have the second one does? Let me phrase that. What does this first one need that the second one has? So if I gave this one an x plus 4, they'd be alike, right? What is this one? Excuse me, minus 4. What does this one over here need on this one that this one doesn't? Oh, x minus 1. So now are they alike? Well, then this is the answer to the question.
If it's not that order, is it wrong?
No, it's just got to be the same items. So that's kind of what you got to do to get the variables alike in the denominators as we go through problems that actually have fractions. See, these problems were called least common multiples because you didn't see any fractions. But it's the same process if it's in the denominator. Now, sometimes you're lucky. Maybe you'll have that 2/5 plus a fifth. Maybe you'll have a common denominator. But sometimes you don't. So I'm focusing more on you don't. I mean, I could have it, but then anybody could add up the top if they had the common denominator, right? They both have an x, but that 4 and that 7 is not on that x. And that's the problem that most students have is they don't understand they're two separate things. They have the same amount of x's. They don't have the same coefficient. What number would 7 and 4 both go into? 28. And wouldn't I need an x on that 28 for these two to match? So what am I going to give this 7x so it turns into 28? 4. All right? That's the whole point to the process, is to give the numerator and the denominator what it takes to make the common denominator work. So now that'll be negative 8 over 28x. What does the second fraction need on the denominator to make this into a 28x? Needs 7. So that's going to make it 35 over 28x. Once you get the denominators alike, you do what it says in the middle, add or subtract. So a lot of times, because of that, it's a lot easier to do this, especially if you got a lot more on top. Plus a negative, because we don't ever really subtract positive negatives. We change it to plus and do the opposite. So 2 negatives add up to what? Huh? Negative 43 over 28x. Now, when I get to the end, then I have to go back and think about what I learned in the previous lesson. You may have wondered, why didn't you start with adding and subtracting? Don't you always learn adding and subtracting before you learn multiplying and dividing? Not in this case. Because when you get to the end, if this factors or reduces, you must reduce it. So we had to learn about multiplying and dividing, so we learn about reducing. Because sometimes this will, but this one will not, right? Because 43 is prime. All right. So let's look at another example. And this time, we've got to have polynomial factoring. That was a monomial problem, and monomials usually are a little bit easier. But I got to factor the bottom of this one. All right, because if I don't factor the bottom of that one, then I can't see what this one needs. That's right, it needs an x plus 2. Because if I give it an x plus 2 on top and bottom, then it looks like this one. Now this first fraction didn't need anything, because the second one doesn't have anything it doesn't already have. So everybody see that? I'm talking about the denominator. Yeah, just the denominator. So now that we've got the denominator together, and we've got it all worked out so that the denominator itself match, I don't have to match the tops, I just have to match the bottoms, and then I multiply and add like terms. But again, this is a subtraction problem. So how about we change it to plus and negative? Because one of the reasons why that's so important is that you're getting ready to distribute, and you want to take that negative as you go. You don't want to do it after the fact because people forget to do it right. So negative 3 times x, negative 3x, negative 3 times 2. It'll have to be minus. That's right. You got to make. That's why we wanted to make sure that we took the negative with it, so we get the right sign over there. Now we can add like terms. How many x's do I have on top? And please don't say 2. 1x, right? If I subtract the like terms. And how much numerical constant will I have? Minus 5. All right. Is that going to cancel either one of my denominators out? No. Because x minus 5 don't look a thing like x minus 2 and x plus 2. That's my answer. Now, one thing I have to warn you about is you'll do like 5 or 6 questions and maybe won't reduce, and all of a sudden one will creep in that will. So you need to ask yourself that question at the end of every problem. Will it factor and reduce, or does it need anything done to it? Because about 1 out of every 10 problems might reduce. Okay, let's try another one. So x minus 6 looks good, right? But this other denominator needs factoring. I bet one of the factors is x minus 6. What goes with negative 6 to make negative 30? And does that add up to negative 1? So sometimes you can get a hint on what you need one of the denominators to factor to because you've got it over here. Now that's not always the case. It could be that that didn't have anything in common with the first one, but it's lucky that it did because the math would be longer if it didn't. So I need to give this one an x plus 5 on top and bottom. And if you've noticed, we're not multiplying out the bottom, are we? That's because you want to see that common denominator. So now I've got to multiply 2 parentheses together with 4 or whatever multiplying process you use. And then I've got to take this negative with it. What does that mean? Right, I'm going to have to change it to addition and change everybody to the opposite. So it's really important I get these two multiplied together correctly because I got to distribute this negative. So I'm still going to have 3x squared on this first one. But over here, notice I didn't waste time writing the bottom again because it's the same, right? I'm just focusing on the top. We're going to do full. First times first means the first part of the parentheses times the first part of the parentheses is. Outer means the first one times the very end, plus 15x. Inner, plus 5x. And then the last item in the parentheses times the last. Now that's full. But you also could have just done 3x times the second parentheses and come back and did 5 times the second parentheses and you got the same answer. But now I got to deal with this subtraction sign right here. So I'm going to change everybody to the opposite. Because you cannot subtract that many terms without changing it. You'll mess it up. Because you'll only give it to the first one if you just use it the way it was written. So how many squareds do I have now? None. Somebody tell me why. That's right, it minuses out. How much is negative 15 with negative 5x? Negative 20x. And then we got minus 25 all over x minus 6, x plus 5. Now, what did I tell you need to ask yourself at the end of every question? Does it factor? Okay. Now, sometimes you may go off and factor it and it doesn't help. Okay, for example, I could take a negative 5 out of that, right? And if I take a negative 5 out of that, what will I have left? Will that cancel with anybody down here that don't factor it? Check it, but don't factor it if it don't cancel. They want the numerator all together, but if it factors and cancels, they'd rather have a more reduced answer. But since this factoring won't cancel, I don't do that. All right, let's do that one. So what do I need to factor?
Take a 3 out.
I like your 3 idea. That sounds shorter. Let me start with that. So if I take a 3 out here, what would I have to do over here? Put a 3 on top and bottom. Okay. Now, let me go with your idea. You want me to factor the top. And not that that's a bad thought, because if the top really factors and would cancel something under it, that's probably a good idea. I don't think this one factors though. But I mean, it could factor and cancel with the bottom. But 9 times out of 10, that's probably not what you want to do. Just focus on the bottom. Factor the bottom, get your common denominator. Now, how much is this going to be over here is going to need this negative distributed to it, and how much will that be? All right. Everybody agree? 48.
Would you make 5 negative 6?
No. Remember what we talked about with fractions? Where's the place the negative always goes? If you make the top and the bottom negative, they'll cancel. It can't cancel. It's distributing the subtraction sign. So now I have 12x squares, because that's all the squares there are. I have minus x, because that's all the x's are. But I got a 9 and a negative 48 that need putting together to make 39. All right. Over 3x plus 11. Now, I could multiply 12 times 39 and try to come up with some factors that might subtract to make negative 1.
Yeah.
Nope.
It's the 3.
Cannot take 3 into anything on the top because the top is a polynomial and the 3 is a monomial. And I keep seeing people do that, and you cannot do that. Unless I can make 2 parentheses out of this where one of them is x plus 11, there's nothing going to cancel. So, my question is, if that's the case, is there anything times 11 that's going to make any of these numbers up here? Well, then I don't guess we're going to be factoring.
Just kidding.
Now, once in a while, you might have 3, and we'll stop. This will be our last one for today. I wrote up a couple more, but they weren't any different than these were. But this has 3 fractions, so you got to make sure that you think about the fact that you really want it to be 3 added fractions. And so I just usually, as soon as I write it down, I make it plus a negative right off the bat because I just think that's easier. Now I have 3 different denominators. What does this need?
2x minus 3.
All right, so we need a 2x minus 3 on top and bottom. Anything else? And an x. So I'll put that out here with the 4. I really should have screwed that over more. Oh well. What does this one need? An x and an x plus 1. One person said x, one said x plus 1, and they're totally different from each other, so I need both. What does this one need? Yes, it needs both of them, unfortunately. So that'll take a little bit longer to multiply down there than these first 2. Yes, I did, but I need to scoot it over so we can see it. No, I just squeezed it in there, and it wasn't really a good squeeze. So one of the things you might want to do when you're doing this is think about the monomials first so you can get them in there and then put your parentheses you need beside it, because as you saw, if I don't leave room to put this x, it's hard to see. So now that I've got it all straightened out, we're going to multiply out. This first fraction is just distributive. So that's 8x squared minus 12x. And I'm not even going to write the denominators because it's not worth the time. I already know what that's going to be in my final answer, don't I? No. Now we're going to do negative 5x times this one. So what will that be? Minus 5x. Because you got to take negative 5x times 1 also. So whatever's in front of the parentheses, we're distributing, right? Now over here, I got to multiply these 2 together and come back and multiply it by negative 4. So sometimes you might want to go do some scratch work and then come back and multiply by it. So a lot of times I might write that above the problem so that then I can see how to multiply by the 4 so I can come in here and write what I really want. So x times 2x is 2x squared. X times negative 3 is negative 3x. 1 times 2x is 2x. And 1 times negative 3 is negative 3. That's got to be multiplied by negative 4. So negative 8x squared plus 12x minus 8x plus 12.
May I have your attention, please?
Because 3 times 4 is 12.
The baseball game will be at 5 p.m. this evening. Again, varsity only. Baseball will play at 5 p.m.
I had some white terms that marked out. Mm-hmm.
It's hard to tell. It looks like a negative. There.
So, I don't think that's going to factor. What do you think? No. They usually don't. But there'll be one every so often. So in Canvas, there's an assignment. You should be able to do most of the front page with what I taught today. I'm going to finish teaching this on Monday and teach you how to do the back, which is what's in Canvas on the second page. So, you know, if you get bogged down and you think some of the ones near the bottom are too hard, then stop, because you'll have time on Monday to work on it. Up to about 13, it's more monomial. It gets a little bit more polynomial as you get from 14 to 19. So you should be able to do most everything on this front. Just stop, and we'll finish it on Monday, because we only got 6 that's on the second page. Now we're having a test next week on this unit. We've got one more lesson after this one.
Rogers, please come to the office. Brittany Rogers to the office.